Morning everyone, I am K. Mamatha, pursuing second MSc Microbiology in Central University of Tamil Nadu. My topic is primary, secondary and tertiary treatments of wastewater. Wastewater treatment. The main aim of wastewater treatment is to enable wastewater to be disposed safely without being a danger to the public health and also environment. Another important aim for the wastewater treatment is to recover energy, nutrients and water and also other valuable resources from the wastewater. Now we can see the types of sewages. So there are mainly three types of sewages. Those are domestic sewage, industrial sewage and storm sewage. So first one is the domestic sewage. Domestic sewage, it is nothing but the word we can understand that the water which is coming out from the houses and apartments, this is called the domestic sewage. And industrial sewage is nothing but the water which is coming out from the industries, it is called industrial sewage. And now coming to the storm sewage or storm water, it is like a runoff from precipitation that is collected in a system of pipes or open channels. So now we will see the composition of the wastewater. Wastewater mainly consisting of 99.9% of the water and 0.1% of the solids. Solids are nothing but the organic and inorganic solids. In this mainly the organic solids will be most. Like it can occupy 70% in the wastewater. Organics are nothing but it is like proteins, carbohydrates, fats. And inorganic are nothing but sediments, salts and metals. Now, municipal wastewater treatment systems. Here we can see preliminary treatment, primary treatment, secondary treatment and final treatment. Preliminary treatment, it includes the removal of the materials that can cause operational problems, which are equalization basins are optional here. And primary treatment, it includes that it can remove 60% of the solids and 35% of the BOD. And secondary treatment, it can remove the 85% of the BOD and solids. And final treatment, it includes the disinfection. Now coming to the different types of treatment. First one is a primary wastewater treatment. Here you can observe the diagram. Here you can see the influents. Influents are nothing but the water which is coming into that plant. Those are called influents. First here we can see the screen or else bar screens. The first thing to happen to the wastewater as it enters into the plant is for it to pass through the bar screens, or else it is also called as bar racks. These can remove the objects in the wastewater that are large enough to be caught in series of screens. These bar screens are different types like trash racks, manually cleaned racks and mechanically cleaned racks. So first one is the trash racks. These are having larger openings. It is like 40 to 150 micrometer, and these can be used to remove the larger objects which are entering into the plant. And second one is the manually cleaned racks. These are like smaller openings, 25 to 50 micrometer. These are not often used except infrequently used bypass channels. In often we can use mechanically cleaned racks. Mostly they are having smallest openings like 1 to 40 micrometers. So obviously we will use this mechanically cleaned racks can be used. So there are like two channels for bar screens are always available, allowing for one to undergo maintenance and while the plant is still in operation. We have already seen the bar screens. Now we coming to the grit removal. Grit is the term used for the small and dense materials such as sand, grit and broken glass. So if not removed separately, grit can cause wear or damage to the mechanical devices in a treatment plant. There are several methods to remove the grit, though the most common is to send it through a channel where the speed of the water is such that the grit settles and can be removed, while the rest of the water can be flow onto the further treatment. Further treatment is nothing but the sedimentation process. Like bar screen, so I have already mentioned bar screens having two channels. Like that, this grit removal also having two channels. One is for one to be cleaned or repaired while the others remain in use. Now coming to the sedimentation process, once the larger and smaller objects and grit have been removed, the rest of the suspended materials can be removed by using the sedimentation process. Now coming to the secondary wastewater treatment. In secondary wastewater treatment, it is the second stage of wastewater treatment. In primary wastewater treatment, some of things like solids, colloidal particles, oil and grease can be removed. In secondary treatment, biological treatment is done on the wastewater to remove the organic matter which is present in the wastewater. So it can be performed by indigenous and aquatic microorganisms like bacteria, protozoa. They can consume the biodegradable solids, contaminants like sugars, fats, detergents and food waste. These processes are sensitive to the temperature. Where there is a increase in the temperature, that rate of the biological reaction will be increases. Like temperature is directly proportional to the biological reactions. Secondary wastewater treatment, it can be divided into two different treatments. First one is the aerobic treatment and second one is the anaerobic treatment. The name by itself only we can understand that aerobic treatment is nothing but in presence of oxygen they will do the treatment. In anaerobic treatment, it is nothing but in the absence of oxygen they will do. So in aerobic treatment, the aerobic wastewater treatment, it is a biological treatment that can uses the oxygen to break down the organic matter, and also it can remove the other pollutants like nitrogen and phosphorus. Aerobic treatment technologies are like activated sludge process and sequential batch reactor and moving bed biofilm reactor and membrane bioreactor. So I'm mainly dealing with the activated sludge process. Anaerobic treatment Anaerobic treatment is a process where wastewater or materials like microorganisms without the aid of dissolved oxygen. As I have mentioned earlier, I am dealing with the activated sludge process. It's a process that was developed around 1912 to 1914 for the treatment of sewage and industrial wastewater. There are many different designs, but in general all activated sludge process have three main components: an aeration tank that serves as a bioreactor. Here you can see the diagram, like aeration tank, the green color one, it is also called as a bioreactor. And second one is a settling tank for separating activated sludge solids and treated wastewater. And third one is the return activated sludge. Now coming to the process of this activated sludge process, the activated sludge process in wastewater treatment, it mainly involves injecting oxygen or air into the raw unsettled sewage. The solids are smashed during this process. The first, you can see the diagram, right? The first influence enters into the bar screens. Here the larger objects will stay there, and minimal objects based on the bar screen holes, the objects will enters into the grid chamber. This grid chamber is similar to the grid chamber that I have explained in the first primary wastewater treatment. The next it will enters into the primary clarifier. Next it will enters into the aeration tank. Here the live bacteria sink to the bottom of the tank, while the dead bacteria float to the surface. While the live bacteria return to the digestion chamber, clean water can be discharged into the soak away or water course. It can comes out as a effluent. Second one is the activated sludge process by sedimentation process. Separation of the biomass and other solids from the wastewater, it is called sedimentation. The portion of the sludge which contains the living microorganisms is returned to the aeration basin. The activated sludge process, some of the substrates will completely oxidize to harmless end products. Those are like carbon dioxide and other inorganic substances to provide the energy for growth of the microorganisms. Oxygen must be supplied continuously, and this is a major energy consuming operation in this process. As I have already mentioned, oxygen is the main important thing. The basic components of an activated sludge sewage treatment system includes an aeration tank and a secondary settling basin or clarifier. So now coming to the advantages of the activated sludge process are the quantity of the unwanted sludge is reduced, and also it is extremely dependable, and also it is less complicated, and cost of being reduced, and this method can be orderless, and also beneficial bacteria reseed themselves in the sewage treatment plants, and also activated sludge treatment process allow for longer emptying intervals. Now coming to the anaerobic wastewater treatment, it is a type of biological treatment where anaerobic microorganisms are used to break down the break down and remove the organic contaminants which are present in the wastewater. While these anaerobic treatment systems may take variety of forms, they generally include some of forms of bioreactor or respiratory capable of maintaining the oxygen free environment needed to support the process of anaerobic digestion. So the main anaerobic wastewater treatment includes the anaerobic lagoons. Anaerobic lagoons, it can be like man-made ponds. It is ranging from 1 to 2 acres in size. As you can observe in the diagram, it is up to 20 feet deeply, and they are used widely for the treatment of the agriculture wastewater resulting from the meat production, as well as treatment for the other industrial wastewater streams. As I have mentioned in the primary treatment step in municipal wastewater treatment, this wastewater is typically piped into the bottom of the lagoons, where it settles out to form an upper liquid layer and a semi-solid sludge layer. The liquid layer, it can prevent the oxygen from reaching to the sludge layer, allowing the process of anaerobic digestion to break down the organic materials in the wastewater. And next treatment is a anaerobic sludge blanket reactor. Sludge blanket reactor, or a type of anaerobic treatment where the wastewater is passed through a free floating blanket of suspended sludge particles. As the anaerobes in the sludge, they can digest the organic particles which are present in the wastewater. They can multiply and collect into the large granules, and they can settle down at the bottom of the reactor tank. These microorganisms can be useful for further reactions. The treated effluents that can be flows upward and out of the unit. Biogases that results from the degradation process are collected by the collection hoods throughout the treatment cycle. Now coming to the tertiary wastewater treatment, it is a final stage of the multi-stage wastewater cleaning process. This third stage of the treatment, it can remove the organic compounds, bacteria, viruses and parasites. Removing these harmful substances, it makes the treated water safe to reuse. Like if we remove all these compounds like bacteria, virus, parasites, we can reuse this water, and we can also recycle or release it into the environment. Tertiary treatments of the wastewater, it means final filtration of the treated effluents. When needed, it sometimes involves using alum to remove phosphorus particles from the water. Alum, it also causes any solids that were not removed by primary, secondary wastewater treatments to group, so they can be removed by filters. Now coming to the disinfection, an important part of the wastewater treatment involves the addition of the chlorine to the final effluents before discharge. Means before discharging into the environment, first we have to add this chlorine to that wastewater. This process injects the chlorine into the headworks of the serpentine effluents detention chambers. Chlorination in wastewater treatments, that can kills the bacteria, virus, and also it eliminates the parasites such as Giardia and Cryptosporidium, which can cause very serious illness to the people. And in summary, this process disinfects water so that it is safe to reuse and recycle. Now coming to the process dichlorination. The final stage of the tertiary wastewater treatment process, it involves the removing of the chlorine that was used to disinfect the water. This step is very important because chlorine is harmful to the aquatic life. Chlorine also reduces biological water quality when it is present high concentration. To remove the chlorine, a compound called sodium bisulfate is added to the water. Chlorine ions which are present in the water, they can react with this chemical, and those can be removed. Once the chlorine concentration has been reduced to a safe level, the treated water is now considered clean enough to be safely released into the environment. These are my references. I hope you all enjoy my session. Thank you, ma'am, for giving me this wonderful opportunity. Thank you, one and all.